Hello guys, in this video we will look at return on investment for hybrid systems, meaning solar systems with batteries. We will start with a system that has a small battery. And these examples are just approximations, and obviously system cost can vary quite a bit from place to place and house to house because of factors like roof type and if we need to make a frame or not, things like that. So please consider these examples as only food for thought, but they are based on examples from real life, so it's absolutely relevant. It's just that it doesn't have to be like this for you. It might be cheaper and it might be more expensive. Anyway, so we're gonna start. This is a 5 kilowatt system with 14 panels. So it's gonna produce about 20 to 25 kilowatt hours per day on average. And on average is obviously the keywords, because it's going to be very low when you have little sunshine, and it's going to be very high when you have a lot of sunshine. But the average is going to be around there, maybe 24, 25 on average. That will result over the year if you have reasonable direction and reasonable slope. Doesn't have to be optimal at all, but if you are not too far away from 15-degree slope, can be as low as 10 or even lower, and up to 30, even higher. But once you get to 40, then you're starting to lose somewhat significant percentages of the production. And also direction, if you have north very steep, for example, that's going to hurt you, absolutely. But otherwise, you're going to have pretty good production over the year. The keyword is over the year, because you will see variation by season also. That's how solar works. You have variation, but you also have significant averages. So even though you have variation, you have significant help also in the months where you have rain season and stuff like that. So over the year, we'll estimate that you have savings of 3,000 per month, equal to 36 per year. So that's the assumption here. Conservative assumption, absolutely. Because this has a battery, a 5 kilowatt hour battery, the starting point is obviously quite low because you have to invest almost 400,000. So the point where you get payback, or where you have your money back, is about 11 years. So if you remember our video about on-grid systems without batteries, you remember that we had return on investment there between 3 and 6 years, depending on size of system. So we're looking at around the double with the battery, and that's pretty much what I've always told customers, that return on investment is going to be take around double amount of time. But it's not too bad. It's not many years ago that actually even systems without batteries had return on investment or get your money back in 10, 11 years. If you look 10, 15 years back in time, that's where solar technology was. And that was seen as a good result. So that the technology has gotten so far that without batteries we're down to 3 to 6, and with batteries we are up here somewhere around the double somewhere. That's actually an incredible improvement of the technology. So it just tells you how far we have come. Now let's put in a few other numbers here, because this can actually, or not actually, it can change, obviously. So let me just give you an example. Let's look at 450 and see how that what happens then with the analysis. Obviously, not obviously, but this is when we increase battery size from 5 to 10 kilowatt hours. 10 kilowatt hours is a normal battery size for a 5 kilowatt system. So this is a very common system. 5 kilowatt with a 5 kilowatt hour battery is also common, but then I would say then you are focusing on the UPS only, then you are not focusing on using electric much at night. So that's actually a pretty nice setup if you plan it from the start to size the battery system after what you think you're going to use when the power is cut only, and do not plan to use it so much for normal use. So, because then you can cut the cost of the batteries. If you are unsure of how to think regarding things like that, please let me know, and I can talk you through a few examples, because it's really important that the goals that you have in your own mind, that we start with that when we design a system. And some of those goals can change the price a lot, because the price of batteries are so high now. So anyway, this is with the 10 kilowatt hour system. So obviously we're starting lower, and we're going to cross the line at 12 and a half. This is wrong. So this number is wrong. It's 12 and a half years. And then we can look at bigger systems. Let's try one, just some examples. We have on 900,000, but with double the amount of panels and energy. So we're going to put in 72 here. So now we're up to 28 panels, and we have 20 kilowatt hour batteries, just example. Then we get payback after a little bit more than 12 years. Again, ignore this number, it's just not being updated. Doesn't matter. This is the correct one. So it's about 12 and a half years that you have payback year. So that's another nice way of looking at bigger systems. The 10 kilowatt with a bigger battery, you are having payback time after 12 and a half. Compared to on-grid systems, there are a few things that changes other than the pure payback and the UPS function and stuff like that. With the inverters, you have a slightly increased risk of failure, just because hybrid inverters are more complex. So how to add that? Well, you could change this number to a little bit lower to reflect a little bit higher risk. But you could also say that the end of the analysis should be a few years shorter on a hybrid system, just because of the increased risk of failure. Doesn't mean that the risk is high, absolutely not. It just means that it can be a factor if you want a complete picture with the technology. So normally we would say that an on-grid inverter has a lifetime of plus minus 15 years. Reasonable assumption, many experts think so. And the hybrid inverter would be some years less than that. But doesn't mean that they are destined to fail around that year, absolutely not. Because they are improving the technology year by year. So the failures that we see now could already have been changed into something a lot better. It's obviously hard to predict all these things, and hard to know all these things 100%, because you have to wait so long time to see the actual failures. And there's no way to model those 100%. So you just have to assume that the technology is improving, which I think is a fair assumption. So that was a little bit about return on investment for battery systems. And as I said in the other video, there's a lot of changes you can make here. You can have assumptions of changing electrical prices. You can have assumptions of, degradation in the panels that can change this. All kinds of factors. So as time goes by, we can change this prognosis and analysis depending on factors specifically related to specific quotes. That's the goal. So, okay, guys, take it easy.